On July 20, 1969, humanity achieved a historic feat: we landed on the Moon. Despite the incredible achievements of the Apollo missions, however, there was one aspect of the Moon that remained out of reach: the dark side. This mysterious region has remained shrouded in secrecy, but now, thanks to the James Webb Space Telescope, we can finally see what lies beyond the horizon, unlocking a new era of lunar exploration and discovery. Join us as we dig deeper into what the images look like and what secrets have been hiding in the dark this entire time. The James Webb Space Telescope, JWST, is a revolutionary new telescope that's transforming our understanding of the universe one discovery at a time. Designed to succeed the Hubble Space Telescope, the JWST is the largest and most powerful space telescope ever built. It was developed by NASA in partnership with the European Space Agency and the Canadian Space Agency, and launched on December 25, 2021. From that moment onwards, it pretty much changed everything. The JWST is equipped with a suite of advanced scientific instruments that allow it to observe the universe in unprecedented detail. Its primary mirror, over 6 meters in diameter, is more than twice the size of Hubble's mirror and is coated in a layer of gold to improve its sensitivity to infrared light. With this capability alone, the JWST is stronger than any other telescope NASA has ever used. But that's not all. The telescope is positioned at a special point in space called the second Lagrange point, located about 1.5 million kilometers from Earth. This position allows it to observe the universe with minimal interference from Earth's atmosphere and heat, making it ideal for studying the earliest and most distant objects in the universe. The JWST has 4 main scientific goals that aim to expand our understanding of the cosmos. The first goal is to observe the first galaxies that formed after the Big Bang, located so far away from Earth that you need extremely sensitive instruments to even detect them. By studying these ancient objects, scientists can learn more about the origins of the universe and the processes that shaped its evolution. Stars, for example, form through the gravitational collapse of gas and dust clouds, but the exact processes that drive this collapse are still not well understood. By observing star-forming regions in different parts of the universe, the JWST will help scientists unravel the complex forces that lead to the birth of new stars and provide new insights into ancient stars that were previously invisible. Another area of interest is the development of galaxy structures. Galaxies come in all shapes and sizes, from giant elliptical galaxies to smaller spiral galaxies like our Milky Way. The JWST will help us understand how these structures form, evolve over time, and interact with each other. Understanding how galaxies form and evolve is crucial to our overall understanding of the universe. Galaxies are complex systems, shaped by the interplay of gravity, gas, dust, and other forces. The JWST will study interactions between galaxies, including collisions, mergers, and gravitational influences, to help scientists gain insights into the processes that shape the universe on a grand scale. In addition to these cosmic mysteries, the JWST will also provide deeper insights into the formation and evolution of planetary systems, including our own solar system. One of the most exciting areas of study in recent years has been the search for exoplanets, planets orbiting stars other than our Sun. Thousands of exoplanets have already been discovered, and many more are waiting to be found. The JWST's advanced scientific instruments allow scientists to study exoplanets in unprecedented detail, with the goal of determining whether they might be capable of supporting life as we know it. One of the primary ways the JWST will study exoplanets is by analyzing their atmospheres. By looking at the light that passes through or reflects off an exoplanet's atmosphere, scientists can learn about the gases present, including oxygen, carbon dioxide, and water vapor, all key indicators of a planet's potential to support life. For example, on Earth, the presence of oxygen in the atmosphere is a clear sign that life exists here, as oxygen is produced by photosynthetic organisms like plants. If a similar signature were detected in the atmosphere of an exoplanet, it could strongly suggest the possibility of life there as well. In addition to studying exoplanet atmospheres, the JWST will analyze the compositions of these planets by measuring the amounts of various elements on their surfaces or interiors. This can provide insights into the history and formation of these planets. If water or other volatile compounds are detected, it could indicate that the planet formed farther from its star and migrated inward over time. Understanding how this process could potentially happen can help scientists figure out if it's occurring on Earth and how to prevent any catastrophic consequences for our survival. The focus of the JWST is not just on Earth, but also on the study of planetary systems around other stars that are similar to our solar system. The telescope's research goes into detail about the architecture of these systems, helping scientists learn more about the processes that led to the formation of our solar system and how common such systems might be across the universe. The JWST can even study the outer planets of other solar systems, which are often difficult to observe with most telescopes. This will help us learn more about the conditions that led to their formation and their potential for supporting life. All of this makes it clear that the JWST isn't just an average piece of scientific technology. It's one of the most important tools ever created in history, and if it can provide such detailed insights into galaxies and our solar system, it can do even more for our own moon. Indeed, the JWST is now exploring the dark side of the moon, a place where secrets have long lurked, waiting to be uncovered. Though we see the moon all the time, we only see one side, the side fully lit and facing Earth. But what's really going on the other side? That's a question scientists have been asking for years. In 2019, China's Chang'e 4 spacecraft became the first to land on the moon's far side. It brought with it a rover called Yutu-2, which made a surprising discovery, an unknown material unlike anything else on the moon's surface. Scientists believe it could be a fragment of the moon's mantle, the layer between the moon's crust and core, made up of dense iron and magnesium-rich rocks. If the material is indeed a fragment of the mantle, it would offer valuable insights into the moon's inner workings and the geological processes that formed it. Some conspiracy theorists, however, believe the unknown material could be a sign of hidden structures on the dark side of the moon. Adding to the mystery are lunar swirls, light-colored patterns on the moon's surface that resemble swirls against the dark. Scientists think they are caused by the moon's magnetic field interacting with the solar wind, but these swirls are only found on the near side, leaving the dark side an unsolved mystery. Further fueling curiosity is a mysterious hum heard during the Apollo 10 mission in 1969. Astronauts Eugene Cernan and John Young described a strange whistling sound while flying around the moon's far side. Though NASA concluded that radio interference likely caused it, conspiracy theorists believe it might indicate alien activity. Given that the far side of the moon is shielded from Earth's radio waves, this theory has persisted. While these claims remain largely unsubstantiated, they continue to fuel speculation about what might be lurking on the far side of the moon. Some theorize that aliens might be using satellites to spy on us from there, although it would be difficult to hide these satellites due to the heat they produce. Regardless, this possibility keeps imaginations alive, especially when considering the moon's role in blocking radio signals from Earth. Speaking of signals, there are also transient lunar phenomena, TLPs, mysterious flashes or glows observed on the moon's surface. First recorded in the 9th century, TLPs remain enigmatic. Some scientists believe they could be caused by meteoroid impacts or volcanic activity, though the moon is considered geologically inactive. If volcanic activity were still present, it would be a significant discovery, challenging our understanding of the moon's history and evolution. However, such activity would also pose risks for future lunar bases, as gas and dust from eruptions could damage equipment and create health hazards for astronauts. NASA plans to send humans back to the moon by 2024 through the Artemis program, sparking new interest in the moon's dark side and reviving rumors about secret bases. During the Cold War, for example, the U.S. military proposed Project Horizon, a plan to establish a permanent base on the moon for housing nuclear missiles. Though President Eisenhower rejected the idea, some conspiracy theorists believe the project continued in secret. China, too, has made strides in space exploration, notably with its Yutu-2 rover, which recently captured an image of a peculiar structure on the moon. Although it turned out to be a rock, the discovery ignited speculation about the possibility of extraterrestrial life or secret lunar bases. Recently, NASA introduced the ShadowCam, designed to capture high-resolution images of the Moon's permanently shadowed regions. One of the first images, taken of the Shackleton crater, revealed remarkable details about a path carved by a boulder, providing insights into the geological processes shaping the Moon. As the Moon continues to reveal its mysteries, it's clear that we still have much to learn. What other secrets might be hiding on the Moon? Share your thoughts in the comments below, and if you enjoyed this article, give it a thumbs up. See you next time.